All right, so it says write a polynomial function of minimum degree in standard form with real coefficients whose zeros include the following. So on example 2, they told me I had zeros of -3, 4, and 2 minus I. So I'm going to write that out. So they told me that my zeros are at x equals what? -3, x equals 4, x equals 2 minus I, and we should know there's a fourth one, right? What is my fourth zero?
2 plus I.
Right, because imaginary ones come in conjugate pairs. So if 2 minus I is a 0, 2 plus I is going to be a 0 as well. All right, now it says of minimum degree. So how many zeros do I have total? 4. So that means my largest exponent is going to be a 4, okay? So if I know that those are my zeros, then I can find my factors. So what are my factors going to be? Well, that's where we take those zeros and we put them back inside with x. So this first one, if x is equal to -3, when I move the 3 back over, I get a factor of x plus 3. And x equals 4 gives me a factor of x. Good. And then if x is equal to 2 minus I, when I move this over, it's going to give me -2 plus I. You got to change the sign to move them over, right? And then the same thing on this one. When I move it over, it's going to give me x -2 minus I. All right, so if I know my factors, then I know my function in polynomial form, in factored form, because then I just say f of x equals, and I'm going to list my factors. So x plus 3, x minus 4, x minus 2 plus I, and x minus 2 minus I. But did it ask for it in factored form? No, it said standard form, which is that's where we have to have all the different terms, right? So I have to do all the multiplying. So how many factors do I have? Anybody? 4. So I could multiply 2 of them together and then the other 2 together and then multiply those answers together. Does that make sense? So remember, you want to multiply your imaginary ones together. So these 2 need to go together. And so we're going to multiply those 2 together as well. So let's do the first 2. So we're going to take x times x, which is, y'all can help me here. All right, and then x times, be careful, that's a -4. And then 3 times x, which is, and 3 times -4, which is, do y'all want to go ahead and simplify that one or multiply the next one first? Simplify it? All right, so, but remember, we got to come back and do the second part of it. So this just gives me what, x squared. I can combine those. Uh-oh, I put an I instead of an x. I'm so sorry. So -4x plus 3x is -x, and then minus 12. All right, now for the fun stuff. Do y'all know how to do like the Punnett square? Is that what it's called?
No.
From chemistry?
No.
Huh?
It sucks.
Okay. Yeah, but the only thing I really like about it, yes, that right there, is that it keeps my work neat and organized. Because right now, just look up here and then I'll erase some of this so it doesn't look so messy. We're going to take this x times all 3, and we're going to take the -2 times all 3, and we're going to take the I times all 3. It's going to get pretty messy. I like the Punnett square when it comes to this because it organizes my work really well. So, which you can do you can distribute your x, your -2, and your I, and you'll get the same answer. But I'm going to go ahead and set up my square. So I know it's 3 terms times 3 terms. And you could do this on the one we just did. You can even do it when you just distribute one term if you want to. So I know it's 3 terms by 3 terms, so I need a 3 by 3 box. I'm going to put one of them on top. It doesn't matter. I'm just going to go ahead and put my first one on top. And one of them down the side. So I'm going to put the other one down the side. So now remember, whatever's going to go in this box is what's in its row and its column. Whatever's going to go in this middle box right here is from its row and its column, okay? So for this first box right here, the top left, we're going to take x times x, which is x squared. Now I'm going to go across. So my next to the right of that, I'm going to have x times -2, which is -2x. And then next to it, I'm going to have x times I, which is xi, okay. And then I'm going to go to my second row, first column. So I'm going to take the -2 there and the x to get it. So -2 times x is and then we'll go across, so I'm going to go to the next one. So -2 times -2 is, and I'm still going across, so -2 times I is, okay. Bottom row, first column. So I'm going to take that -I and that x that's on top. So what's -I times x? -xi. And then -I times the -2, positive 2i. And then the -I times the positive I, which is -I squared. So I'm going to go through and combine like terms. Actually, I'm going to write it underneath it first. All right, so we have an x squared, correct? Now look here, I have a -2x minus 2x, which is what? Good. Now this one's a little weird because they're not all, a lot of times they'll come out in the diagonal, but I have that 4 stuck in there. But I have xi minus xi, what is that? It cancels, so I have that plus 4 there. I have -2i plus 2i, which cancels, right? And then I have that minus I squared. So that's what I'm going to write there. So x squared minus 4x plus 4 minus, but wait, what's I squared? -1. And so here I'm going to do x squared minus 4x. I can combine these two, they're like terms. So 4 minus a -1, which is 4 plus 1 is 5. All right, so now guess what we get to do? We get to do it again. We get to do those two times each other. So again, it's 3 terms times 3 terms. So I'm just going to go make my square. Now, if you want to distribute, you're more than welcome to, okay? So 3 terms times 3 terms. So I need a 3 by 3 box. And put my, no, because we combined the last two because it was a -I squared. Remember, I squared is -1. And so we had minus a -1, which made it plus 1. All right, so when I set this up, I'm going to put my first term going across, my first factor going across the top. And my other factor going down the side. All right, and so let's take a minute and just do that real quick. All right, so I did my Punnett square over there, and then I pulled my answers out and put f of x equals in front of it, because we were done multiplying.